Good morning, everyone.
Good morning, ma'am.
Yeah, should we wait for a few more minutes till everybody joins?
Ma'am, wait for 2 minutes. I'll put another message.
Yeah, actually, they should be joining by now. No, every day we're wasting about 5 minutes waiting for everyone.
Yeah, ma'am.
Just remind them. Otherwise, we'll start.
Yes, ma'am. You can start.
Yeah, okay. Um, okay, in yesterday's class, we had learned about SNMP, Secure Network Management Protocol, and we also learned a little bit regarding network management. What is network management? Like configuration, fault management, performance, security management, and accounting management that we learned yesterday. And I had told you a little bit about SNMP. Okay. So today what we have to learn is this aspect of network management, which is called as security management. Now we all know that when we have a network or when we have internet, our messages, our data is being transmitted from one point to another. So we need to ensure the security of that data. We need to ensure that the data reaches the destination safely. This is very, very important because you are going to make use of public networks. You are going to make use of your data could be available like open access. So if at all it is confidential data, then definitely it needs to remain secure so that only the necessary and the authenticated users are able to see that data. So I don't have to stress upon security. You know very well. For instance, if you people are chatting on with your friends, whatever you're talking between two friends, it should remain secure between the two friends itself. Or for that matter, very confidential data, like maybe data related to military services of a particular nation. If that is being transmitted, then definitely maintaining security of that data would be of highest importance. So security management or security services are really very important. What we need to know right now in security services is that security services are basically divided into two types. Now there's a small mistake in this slide. Just 1 second. Huh? Yeah, I'm sorry about this. Let me start the slide once again. Okay. Generally, when we talk about security services, we look at security of a network from 2 points of view. One is the security of the actual message and looking at it from the entity point of view. So security services could be thought of in terms of the message, that is the actual data you're transferring, and the entity, that is the person from whom that message is coming. person or that machine, or from the source, from whom that particular message is coming. Okay. Now, security, if you are looking at the security services or network security from message point of view, we look at it as message confidentiality, message integrity, message authentication, and message non-repudiation. Now, I'll be telling you each one of them. Also, if you're looking at security services from the entity, from the source point of view, then entity authentication is the only aspect which we are going to look into. Okay, we'll have a look at what these are. Okay, so as I was telling you, you can imagine two people interacting with each other over a network, or a message being transmitted or data being transmitted from the source to the destination. Now, when you're transmitting that data or your message from the source to the destination, you need to ensure confidentiality of that message. I was just now telling you that suppose you are trying to transmit some military data from one point to another, then it should remain confidential only to the source and to the given destination. On the way, on the channel, on the transmission medium, it should not be hacked by the hackers. It should not be accessed by malicious users, because they can definitely misuse that data. So maintaining confidentiality generally refers to availability of that message only to the necessary users, not to everyone else. The second one is message integrity. Integrity means as the message was sent, exactly that way only it should be received. Nobody should be able to make any changes to that message on the way. For example, when we were small, we used to play one small game. We used to whisper something in someone's ears, and we used to transmit that message which is whispered from one person to another person. By the time it starts at the source and by the time it is received at the destination, whatever the source has spoken, something else only would be received at the destination. Why this is happening? Because as and how that message is being passed, it goes through multiple people and they make changes to the messages, whatever they understand, they then transfer it. Similarly, when we are trying to send a message from the source to destination, as the source has sent, exactly in the same way it should be received at the destination side. Nobody should be able to make any changes in it. Only then we can guarantee the message integrity. It has remained as it is. Okay. The third point is message authentication. Here, the receiver needs to be sure about sender's identity. Means whosoever has sent, is it that person only has sent, or some impersonation has happened? Now, impersonation means usually on internet or on Facebook, someone may put a photograph of, say, Hrithik Roshan, but it is actually not Hrithik Roshan. It is one among you. So he is trying to impersonate Hrithik Roshan. What is happening there? You people start getting messages, and looking at that picture, you start feeling that it is from Hrithik Roshan itself. So you are not going to be sure there that it is an authentic message. It is a correct message coming from the correct person. So message authentication is a process in which the receiver becomes sure about the sender's identity. Okay. Then message non-repudiation. Non-repudiation means once the message has been sent, the sender should not be able to deny that he has sent that message. Means suppose from a particular email account you have received a particular email. Now, tomorrow you may say, I got this malicious email from one particular email account. That person may say, I have never sent that email. So we should have mechanisms where we are able to prove that a particular person only has sent that particular email or that particular message. Means the sender should not be able to deny. Tomorrow he can't say, I never sent the message. It's like, you send some message from your, web page, or from your email account, or from your chat ID, and later on say that I never sent it. It has never come from me. Now, the sender should not be able to deny that he has sent a message. That is called as message non-repudiation. Generally, even if the sender denies it, it is up to the receiver to prove that this data has come from the particular ID or from a particular sender. This is called as message non-repudiation. Okay. And the last is entity authentication. Now, if entity means user, if at all a particular user has sent the message, then we should be able to verify whether it has come from the same person or not. That is called as entity authentication. Now, message authentication and entity authentication are almost same, but here we are referring to the message content, the text, and here we are referring to the user who has sent that message. Okay, so we will quickly understand what these are. Security services are important, and they are applied to two, they are looking at it from 2 points of view, that is from message point of view and entity point of view. Maintaining confidentiality of the message, maintaining integrity of the message, authenticating that the message has come from a particular user, and the user should not be able to deny that he has sent a message. These are the aspects that come under message. And under entity, we should be able to authenticate, we should be able to check, verify whether the message has come from an authentic user or not. Okay, now we will start with this one by one. We are first going to learn message confidentiality, then integrity, and lastly authentication. Okay, so confidentiality. I was just now telling you our data that we are trying to transmit over a network needs to remain confidential. Confidential means nobody should be able to see it. Nobody should be able to hack it or access it. And that's why most of the times a mechanism is used on networks to encrypt your data, and that is called as cryptography. What is cryptography? Cryptography is a mechanism in which you try to encrypt your data. Encrypting means encoding. You encode your data at the sender side. At the receiver side, it gets decoded. This mechanism of encoding and decoding, or encrypting and decrypting, is called as cryptography. Now you are going to learn lot of details about cryptography in the in the fifth semester, when you will be learning about one of the subjects that you have there is about cyber law and all that. There you will be learning about cryptography. So today in short, I will try to tell you how confidentiality is maintained with the help of cryptography. Generally, cryptography is implemented with in two ways. One is symmetric key cryptography. One more is called as asymmetric key cryptography. So first, we'll try to understand what is a key. Generally, I want you all to have a look at this diagram. Generally, the data or the text that we want to send, which is generated at a particular machine, is called as plain text. If you all can see this diagram. Okay, suppose there's a user called Alice who is sitting on one particular machine. She wants to send the data to another user called Bob. Okay, now that data is very, very confidential. So whatever is the data, that message which is generated by Alice, we call it as plain text. Plain text is never encrypted. Before encryption, the original text that we have is called as plain text. Now, to this plain text, generally, an encryption algorithm is applied and a key which is shared between the sender and the receiver. This is called as a shared key. The same key is available at the sender and the same key is available at the receiver. A key could be something like a code that you are applying to your data to access the original message. Like, sometimes when you are installing some software, it will ask you to enter a key. Key is a unique number there. Once you enter that key, then your installation process will become complete. Like that, your actual data, to it, some encryption algorithm is applied, encoding algorithm is applied, and a key which is shared between the sender and the receiver. That key is called as a shared secret key. Now, since both the users are using the same key, that's why it is known as symmetric. Symmetric means same key is used by sender, that is in our example Alice, and same key is being used by Bob, the receiver, and hence it is called as a symmetric key cryptography. So at the sender side, encryption algorithm and the symmetric key is applied. Once encryption of data is done, then that text is called as cipher text. Before encryption, it is called as plain text, and after encryption, it will be called as cipher text. So cipher text is nothing but encoded data or encoded message. Now this cipher text goes to the receiver. At the receiver side, this receiver Bob will apply the same key and apply the decryption algorithm. What he will get back is the plain text or the original text that was sent by the sender. So have a look at this whole diagram once again and try to understand it. Instead of sending the data as it is, instead of sending the message as it is, we want to maintain confidentiality. So we try to encrypt the data. So what our user Alice will do, her plain text, the original text, to that encryption algorithm is applied, and also the symmetric key, a unique key which is shared by both sender and the receiver, that is applied. Once that is applied, encryption process becomes complete. Then what is generated is ciphertext. Over the channel, over the network, what is sent is ciphertext. At the receiver side, decryption algorithm is applied and also the key is applied to get back the original text, which is called as plain text. So on the way, if anybody tries to access that data, they don't have the key. So they will not be able to decrypt the data, or they will not be able to fetch the data in the original form. This is how we can maintain or ensure confidentiality. Okay. Now, we'll go to the next slide. I'll try to tell you what is meant by how do we ensure confidentiality using a asymmetric key cryptography. Now, the name itself is telling. Symmetric means same. Same key is used by sender as well as receiver. But asymmetric means not same, unsimilar. Something which is not same, we call it as asymmetric. So now the process is same. That is, cryptography means Alice, who is a sender, will have her plain text. She will apply the encryption algorithm, and what along with that, she is going to apply the key. Now, in case of asymmetric key cryptography, there is not one key, but there are two keys. One is called as public key and the other one is called as private key. Public key will be known to everyone, the sender, the receiver, and others also. Private key will be known only to the receiver. For example, you people must have seen how you, if I don't know if you people have gone to a bank locker to key. Generally, you know, people who want to keep their jewelry and all that in the bank, they make use of this in the bank locker. This kind of a mechanism is used. Usually, there is one key, which suppose your mother is keeping her jewelry in the bank locker. She will have one key of that locker with her. So she will go to the bank locker. The manager comes with her to the locker. He will have another key. Now that key that the manager has got is called as public key. So what he does, he puts the public key first, turns the key, and then he leaves the locker. Now what your mother will do, the key that she possesses, she puts that key and then only that locker will be opened. So now there are going to be two keys. One key is called as public key, which is known to the public, and one is called as private key, which is not known only to the user, only to the receiver. So now you can observe in this diagram, the sender, that is Alice, will generate her data, which is called as plain text. Okay, which is known as plain text. Just 1 second. Yeah, so we have Alice who will generate her data, which is original data, which is called as plain text. Now this diagram is really not very clear. Some lines are missing here. To this, the public key is applied and the encryption algorithm is applied to obtain what we call as ciphertext. Now this ciphertext or the encrypted data goes to the receiver. When it goes to the receiver, receiver is Bob. So what Bob will do, he will apply the decryption algorithm. He will apply the public key as well as he will also apply the private key. So only the receiver will know that private key, the sender will be knowing the public key. So the receiver will apply his public key as well as the private key in order to obtain the original text, which is called as the plain text. Such a mechanism which ensures that data is not going to be accessed by everyone on the way, because they will not be knowing the private key. Suppose there's a hacker who wants to hack the data. He will be able to hack only if he knows the private key. So only in this example, the receiver knows the private key. So only the receiver will be able to access the data. Okay. So I have told you now two ways of accessing, of maintaining confidentiality. One is using symmetric key, the other one is using asymmetric key. Okay. All right. The next part that we have to learn is what is meant by message integrity. Okay. Now, just now I was telling you some time back, confidentiality means nobody should be able to access the data. Nobody except the sender and the receiver. Hacker should not be able to hack the data. That is, that is what we call as confidentiality. And that is ensured with the help of encryption and decryption. But along with confidentiality, we also want the data to be integral. Integral means as it is. As the data was sent, exactly it should be received. So data must be received exactly as it was sent. If it is received exactly as it was sent, then we say that the integrity of the message is preserved. So we are happy that nobody has been able to access the data. Nobody has been able to make any changes to the data. Okay. Now I'll give you one example to make you all understand what is meant by message integrity. Suppose there's one person who has made a will. Now you know, no, will means what? Will means, suppose, say my grandfather, he has some property and he wants to distribute his property amongst his children. So he will make a will. Okay. And in that will, he will mention what part of the property will go to whom. Say house will go to eldest son, and the farm will go to the second son, or maybe the vehicle will go to the third son, like that. Okay. That we that suppose a particular grandfather has made that kind of a will. Now this will, if it is executed in the court, anybody can read that will. So it is not required to maintain confidentiality of the will. It is public. Like when a will is made, it is executed in the court, so everybody can read that will. But nobody should be able to make any changes in the will. Now we must have seen in movies and all, people try to change the will. Suppose someone has got a house, he wants the farm also, he may make some changes in the will, and then he may say that this was done by grandfather himself. So what has happened there? Integrity of the will has been lost. Now generally what they do, when a will is made or something is very authentic, they try to put fingerprint on that document. Okay, so suppose my grandfather has made a will, he will execute that will in the court through a lawyer, and he will also put his fingerprint. When he puts his fingerprint, that becomes authentic, because fingerprints are very unique. Nobody can have same fingerprints. But when we are trying to send the data digitally, now what example I gave you was a manual piece of paper, which you find generally, which you find. But here I'm talking about digital data. I'm trying to transmit my message from the source to the destination on a computer network. So our data becomes digital. Then how are we going to ensure the integrity of the message? So have a look at the second point that is there on the screen. The electronic equivalent of a document and a fingerprint pair is nothing but message and a message digest pair. That is, in general, in our society, we make a document, we have some papers, we put our fingerprint and make it integral. But when we are transmitting the data digitally, we can't have fingerprint on that. So what we do is we try to create the original message, which is nothing but the document, and a message digest. A message digest is something that is generated by applying an algorithm or maybe a function. So we are going to create the original message and its digest. Together, the message and the message digest will preserve the integrity of the message. Okay. So to preserve the integrity of the message, that is to generate the digest, generally we make use of a function which is called as a hash function. Now, I don't know whether you people have learned hash functions in DBMS, but in short, I'll tell you, because this is beyond the scope of our discussion at this point. Hash functions are generally mathematical sort of functions which are applied to the original message or the original data to generate what we call as a digest. So when we apply that mathematical function, the original data gets converted into a digest, or it gets encrypted into a digest. Okay. So if you all can see this diagram, your original message is there, which is nothing but our document in our example. To it, we are going to apply a hash function. Have a look at this. We have the original message. Okay. To it, we apply the hash function. Once we apply the hash function, it's sort of a mathematical function. It is written in the form of a program that gets applied to the message. What gets generated is the message digest. Now, this message digest will help us to check the integrity of a particular message. I will teach you how. Okay. Okay, see how creating and how are we going to create a digest and how are we going to check the digest. So now you must have a look at this diagram and understand Alice is the sender and Bob is the receiver. We want to see to it that whatever Alice has sent, exactly same message is received by the by Bob. Nobody in the middle should be able to access that message and change it. For example, suppose you are trying to send a message to a email to your boss saying that you want to take a leave of 2 days, and somebody who's your enemy sort of in the office hacks your message, and instead of 2 days he makes it 10 days. So original message, its content have been lost. To avoid that, now we make use of what we call as a digest. Okay, so have a look at this diagram and try to understand it. We have a sender, let's call her as Alice, and we have a receiver, let us call him as Bob. What Alice will do, Alice will generate her original message. To that message, Alice will apply what we call as a hash function, which converts that message into a digest. Now you have the message detection code. We call it as a MDC. MDC stands for message detection code. So you have already generated the digest. Okay. Now the digest is sent the message as well as the digest, the original message as well as the digest is sent to the receiver. Now what receiver will do? He'll take that message, the given message, and he will also apply the same hash function, and he will also generate the digest. Now look at this, one digest the sender has sent, one digest the receiver has generated. So now understand this process at the receiver side once again. Sender will send the original message as well as the digest. When it goes to the receiver Bob will take the original message, apply the hash function to it once again, and generate a new digest. Now what he's going to do? This newly generated digest and the digest that Alice has sent, both he is going to compare and see. If both are same, then he will accept, assuming that no changes were made and integrity of the data was maintained. Otherwise, if the digest that is generated and the digest that sender has sent is different, then they are going to discard that message. Okay, I hope I'm clear with the process. I will explain once again. Alice will generate the message, apply a hash function, generate what we call as a digest. Now, after generating the digest, then the original message as well as the digest both are sent to the receiver. Let us call this one. I'll try to show this with the help of one. Let us call this digest in a blue color circle as the sender's digest. Okay. So what the receiver will do? He will take the original message, apply the hash function to it, generate the digest, check if both are same. If both are same, then accept it. Otherwise, he is going to discard it. When will both be same? They will be same only when nobody has made any changes to the sender's digest. Nobody has made any changes to the message. If anybody has made changes to the message, the digest sent by the sender and the digest generated by the receiver will never be same. So we will come to know that there was an error or there was some changes made to the existing data. Okay. Now we will. Okay. Now what we'll do is we'll try to understand how message authentication is implemented. Till now we understood message confidentiality and message integrity. Now we'll try to understand how message authentication is executed. Okay, just now we learned that we can make use of a hash function to preserve the integrity of the message. A hash function guarantees message integrity, but it does not authenticate the user. Means it does not, from that we can't come to know whether the data has come from the correct user or not. So suppose, for example, Alice sends a message to Bob. Bob needs to know, needs to be sure if the message has come from Alice or from some other person, say for example, Eve. So how will Bob come to know whether this message has actually come from Alice? For that, we have to implement what we call as message authentication. Now, how does message authentication work? It is almost same as message integrity. Now here also a digest is going to be created by using a hash function. Once that hash function is used, what generally gets created is a modification detection code, MDC. Okay. Now the code can detect if any modification has been done. To provide message authenticity, we need to change the modification code to authentication code. Means we need to not only be sure about the integrity of the message, but also we need to be sure that the correct user has sent us the message. To make you all understand this, let me give you one example. Okay. So now, yeah. So how message authentication works? Have a look at this. Imagine we have a sender and her name is Alice. Okay. And Bob wants to know whether the message has come from Alice or not. So method is almost same. What Alice will do? Alice will generate the original message. To that, she will apply a key. So there is not going to be hash function, but along with that, there is also going to be a key. So to the original message, a key is applied and a hash function is applied, what we call as MAC, message authentication code. And that message authentication code now is sent along with the message to the receiver. So you all can see what is going to the receiver, the original message as well as the MAC method as message authentication code. Now when it goes to the receiver, the method is again same. The receiver, that is Bob, will take the original message, apply the key, symmetric key is there that he will apply, also apply the MAC function and generate the MAC. Okay. Now there is one MAC which is generated by Bob and one MAC which is sent by Alice. I will try to show you with the help of this. This MAC is sent by Alice. I'll write here A. Okay. And this MAC is generated by Bob. I'll write here B. Now what has to happen? The MAC sent by Alice and the MAC generated by Bob, both should be same. If both are same, means Bob can be sure that this has come from Alice and he will accept it. Otherwise, he is going to discard it. Okay. So I have tried to tell you a lot of things. I want you all to tell me if you have followed or if you want me to repeat something once again.
No, I followed.
Followed? Everybody has followed? Okay. Now, there's a little more. We are left with 5 minutes actually. There's a little more. If time permits, I just want to take that part. Okay, should we take up the next part, 5 minutes? Or should we continue tomorrow?
Ma'am, they're asking to explain message authentication.
Once again, this part?
Yes, ma'am.
Okay, I will explain. Now, message authentication means what? First you understand. Message authentication means being sure that a message has come from the correct person only. Okay, that is called as authentication. For example, if I have sent a message to say my friend, let's call her as say X. So when I send that message, X should become sure that the message has come from Asmita only. Like for example, in this diagram, suppose Alice has sent a message and Bob wants to be sure that it has come from Alice only. Because on the network, anybody can do anything to the message. So to be sure that time message authentication happens, this is similar to message integration. Instead of hash function, we make use of a MAC function. Now what is MAC? Message authentication code, which is similar to a hash function. We apply an algorithm. Along with that, we apply the key. So in case of message authentication, two things are going to be used. One is the key and the other is the function. Okay, so the original message, to that we apply the key. We also apply the MAC function, and what we generate is the message authentication code. Now, once this is generated, the sender will send MAC as well as the original message. You all can see here, the original message as well as MAC. Both are being sent to the receiver. Now, when it is received by the receiver will separate. He will take the sender's MAC, he'll keep it as it is. He'll take the original message. To that, he himself will apply the key. And he will also apply the MAC function and generate another MAC. So let us take this example. Let us say this is the MAC. I'll put this in a circle. This is the MAC, which is in blue color. This has come from Alice. Let's call this as A. A stands for Alice. Alice has sent this MAC. And I will now say Bob had generated another one. Okay, Bob had used the MAC function and generated another MAC function. Now I'll put it in red color and I'll call this as B. This is the MAC function generated by, this is the MAC generated by Bob. Now what Bob will do, his own MAC function, which I have put in red, he will compare it with this blue color MAC function. If both are same, then he will accept the data. Otherwise, he will reject the data, assuming that somebody has made some changes, or maybe that data has not come from Alice, it has come from some other user. This method we use to authenticate a message. I hope I'm clear now.
Yes, ma'am.
Okay, so now tomorrow we will take a class at 11 and I will be able to finish your portion tomorrow. Completely it will get over tomorrow, and on Monday I will share the notes with you. Okay?
Yes, ma'am. Okay, ma'am.
Yeah, sure. Tomorrow mostly I'll take at 11 or 11:15. Let's see, I'll let you know.
Okay, ma'am.
Okay. Thank you. I'm going to end this meeting now.
Yes, ma'am. Thank you.